What is intrinsic quantum spin and why does it exist? For 100 years, physicists have said it's just intrinsic. Don't ask. But here's a reason it likely exists, and it comes from holographic data compression. Each particle has its own relative cosmic horizon. Right now, 14 billion light years away. This horizon is made of 10 to the 122 Planck areas, with each Planck area representing one particle that crossed that horizon since the Big Bang. Those 10 to the 122 particles created all the space we see. But here's the problem. That volume of space contains 10 to the 183 Planck-scale volumes. There are 10 to the 61 times more volumes than the surface can encode. The holographic principle says information is stored on the surface, not in the volume. So we've got a massive mismatch. Nature's solution? Inflate the minimum size of a particle's data node to 10 to the negative 15 meters, about the size of a proton. At this scale, there are exactly 10 to the 122 of these holographic voxels filling the cosmic volume, perfectly matching the 10 to the 122 Planck areas on the horizon. Problem solved. One holographic voxel maps to one Planck area. But now we have a different problem. Inside each of the 10 to the negative 15 meter voxels, there are still 10 to the 69 Planck volumes. How does nature compress all that internal information down to one bit? It spins the surface at the speed of light. When something spins at c, time dilation freezes the external view. The clock appears stopped. All 10 to the 69 internal volumes collapse into one instant, one point of information. The spin node becomes point-like through relativistic information compression. And this is why spin must exist in all axes simultaneously. You can measure any direction, so the compression has to work regardless of which axis you choose. The particle maintains this holographic compression continuously by spinning in all possible orientations at once. This is quantum uncertain, not a fundamental randomness, but the necessary motion to keep that region of space condensed down to a single information bit. When you measure spin, you're not revealing hidden answer. You're selecting which axis to collapse the compression into. The first interaction creates a reference point, the second reference point creates a line, and that line defines the axis where spin energy emerges. Before measurement, the spin energy was maintaining compression in every direction. After measurement, it's defined along your measured axis. Intrinsic spin is nature's holographic data compression algorithm running at the speed of light to turn 10 to the 69 Planck volumes within one 10 to the negative 15 meter radius into one measurable bit. Have a great day, and gravity is for the masses.